Hi everyone. I wanted to take just a few minutes to talk about the end of section 2.2, and then I'm going to give you a video and a paper that I was going to hand out in class about the misleading charts, and I'll let you watch those. There's a short video already on Canvas, and I'll show you where that's at the end of this, and then there's also a short video that I added to my videos section that you can watch. They're both about 4 or 5 minutes long, so not too long at all. This shouldn't take very long. We ended yesterday by looking at, if you look at where we were on example 4. We constructed a frequency and relative frequency histogram from the unemployment data set. And so if I were to draw these out, and again, I'll make this available to you on Canvas, for my annotated notes, you can see that over here we have, let's get another little thing, over here we have our frequency versus our unemployment rate. So this is the frequencies with the numbers. And you can see again with the histograms, remember those, all of those kind of bars or lines, these are butted right up against one another. Here you can easily see that we don't have any values between the 7.4 and 8.4. Alrighty, so we don't have any unemployment rates in that range. If we look at the relative frequency, you can see it's very, very similar. Really, the shape looks almost exactly the same, and it should. The biggest difference here is just that instead we have relative frequency on our y-axis or our vertical axis. And so we're just comparing the percents instead. Remember, the reason we would want to do a frequency or a relative frequency graph instead of a frequency graph is if we're comparing, let's say, several different samples or comparing data from different samples that were from different people or something like that, and we had different sample sizes, this relative frequency is going to give me a lot better look at what's happening with it. In this case, if I was looking at unemployment over time, let's say I looked at January of 2019 and then January 2020 and January 2021, at least the number of states stays the same. So I can see how this part changes a little bit. The relative frequency just kind of baselines that all. So anyway, a couple things to comment. You'll notice the little breaks right here, the line breaks. That's showing that we don't include the 0 to 2.4. That's not included in our graph. And then you'll notice that we have the labels. And when you get to the misrepresented tables, you'll understand more about why the labels are so important. If we want to use StatCrunch, and this is the last part I actually have written on here, we can use that to make these. So if I come in, and grab my StatCrunch, and I look, and this one's actually the unemployment data already. So let me pop that pen back in and see. There we go. There we go. All right. So if I go to graph and I come down to histogram right here, you'll see histogram. I can select the columns. I can select the unemployment rate. This looks a little bit different because it's on my iPad. And then we're going to do a frequency graph first. I can say that I want my x-axis label to be the rate. And I would make these prettier if I was going to publish this. My y-axis label is frequency. And then my title is going to be frequency histogram. All right. And if I tell it to compute, what I get is a graph that looks exceptionally similar to my very first one, but it's not exactly the same. So you'll notice that the start of my class, or what StatCrunch calls the bin, is slightly different. So remember, I can go back and edit, and I can say, oops, I wanted to put bins on this, and I wanted to start with 2.4. And I wanted a bin width of 1. And so you can see kind of what we did there, right? I can tell it to compute, and now it looks basically the same. I didn't put the numbers above. I could do that. So when I do the relative frequency graph in a moment, I'll put that above. Very similar process for the relative frequency. We go to graph, we go to histogram again, we select the rate column. This time though, under type, we want relative frequency. I'm going to put in the bins to start with this time. So I'm going to have 2.4 and I'm going to have a bin width of 1. I'm going to put the values above my bar. So that's where you get that, as on display options. Here my x-axis label is still going to be the rate, right? My y-axis label is relative frequency. And here this is a relative frequency histogram. Sorry, my cat is playing with something on my desk. All right, so now we can just say compute, and you can see a histogram that looks basically exactly like the one that we had there on the other thing. Alrighty. So a histogram is one way that we can display quantitative data. That's not where I wanted to be. It's one way to display quantitative data. And the one last thing I want to show you real quick is if I look at, we kind of talked about how there's not one right way, one correct way to show a histogram, and we can change it. So if I go back over to StatCrunch, if I go to applets, and then I go down here to histograms with sliders, I can select the column rate, and I can just ask it to compute. And what this lets me do is it lets me pick a starting point, so I can change my starting point so that I'm all the way over at -1 if I want to, or I can go all the way up to 2.4 for my starting point for my classes. So you can see how the class part here is changing basically where I'm starting at. So I'm going to put it at 2.4 so it looks like ours does for a second. And our bandwidth was 1. This was what ours looked like. The other thing you can notice is what they call the bin width is our class width. So you can see that if I make my class width really, really wide, I get no detail as to how my data is distributed. And so that's not desirable because I can't really tell. I do notice that there's a little bit of a trailing edge over there on the right-hand side. As I make this bin width smaller and smaller and go back closer to where I was with 1, I get more and more detail, right? And if I continue to go and make the bins smaller and smaller, you can see that the detail almost gets overwhelming. If I'm at point 1, I'm basically seeing every single individual data point separately. And that's not exceptionally useful either because I can't really, that doesn't help me see an overall shape to what my data looks like. It's almost too much information. So it kind of tells you why you want to find something in the middle. Even something like 0.8 would work, 0.9 works, 1 works. So you can kind of see the difference. This is just to show a little bit about how we want enough bins to see what's going on, but not so many that we can't see the shape. We don't want so many that it's really hard to see what's happening like I do over here with a bin width of 0.1. Alrighty, so that is that part. The next part we're going to talk about is the one other way to display quantitative data. And so if we look at that, it's called a dot plot. So if we go back to our siblings data, remember with our siblings data, we were talking about the number of siblings that people had in the statistics class. And so we had 0 siblings, we had 1, we had 2, we had all the way up to 7, 3. All right. So this is my number of siblings. And what I'm going to do is I'm going to put a dot or a circle that's about the same size above, indicating how many people had that many siblings. So for 0, there was one person that had 0 siblings. For 1 sibling, there were 4 people, and I still get 1, 2, 3, 4 dots. For 2 siblings, there were 8 people that I surveyed. 1, 2, 3, 4. So I'm trying to make them about the same height and about the same size on my circles. I'm not doing the best job here. For 3 siblings, I had 3 of them. For 4 siblings, I also had 3 of them. For 5 siblings, I only had 1. For 6, I had none, remember, so I'm going to leave that one blank. And then for 7, I also had 1. So what you can see here is I can kind of start to see, if I look at it, I can kind of start to see the shape of this and what it looks like. If I wanted to see kind of the shape of it, it might come down a little bit more, right over in this area. But you can see the general shape of what the data looks like and how it's distributed a little bit. And we're going to talk about this in just a second. So that's what my dot plot looks like. This is a dot plot. And it's of the siblings data that we did earlier in this lesson. So, of course, not to be outdone, if we go to StatCrunch, I can go to graph dot plot this time. And so I'm going to pick the column siblings when I go over there. So let me go ahead and go over to StatCrunch. I'm going to close this one and I'm going to go to my siblings data set. So I already have it loaded here. Again, I'm going to go to graph. This time I'm going to go down to dot plot, which is right here under the violin plot. I'm going to pick the siblings as my column. And then I'm going to add some labels. So I'm going to say number of siblings. And I'm just going to label this dot plot. All right. And maybe this is kind of a frequency one. All right, so we'll put a frequency on the y-axis. All right, so if we hit compute, what you can see, if you look here, is that they've got the number of dots. There's not any values on the y-axis. It's just you would count the number of dots that you have. You can change that dot spacing if you want to space them out a little bit more. But in general, this is just kind of what it looks like, and that's how you make a dot plot. Honestly, we don't use dot plots a lot. Much more likely to use a histogram than a dot plot. But it's worth knowing. So if I talk about the two types of graphical representations or charts that I can use for quantitative data, graphs or charts, however you want to write it, they're the same, right? We're looking at, first of all, histograms, which we spent a lot of time on, and the second one is dot plots. There's one more that I'm not going to go over. You can see when I upload the 2.2 information, the first page of section 2.3, which we don't do in this class, is on there. There's a third option, if you remember seeing them, you've probably seen them in the past, is stem and leaf plots. That would be another way we could represent it. We don't go over those in this class, but it is another way that you might see quantitative or numerical data represented. So these are the three. Remember, no bar graphs, okay? No pie charts or anything like that are used for quantitative data. Those are just used for qualitative data. So we're looking at histograms, dot plots, and stem and leaf plots. Now I'm going to go on to the next page. You can read through the shape of the distributions here. I'm actually going to explain them, and the reason I'm going to the next page is because it shows them, and so it's a lot easier to see what I'm talking about when I look at this and look at the distributions themselves. So if I look at these distributions, the first one that I have here is the uniform distribution. So you can see that on the uniform distribution, that's right here, what I have is the same value, the same frequency across the board for all of my potential numerical data. And this is probably the most common way that I can think of getting this is when I'm rolling dice. So I'd expect to get it when I'm rolling dice. I have an equal chance of getting a 1 as I do a 2, as I do a 3. And so if I roll my dice a whole bunch of times, let's say 100 times, I should get about the same number, within some very slight variation of dice rolling. I should get the same number, assuming it's a fair dice, of 1, 2, 3, 4, 5, and 6. All right. So uniform distributions, it does say it's symmetric. It is symmetric. I don't often use the word symmetric for this one, just because I tend to use uniform because it's kind of a special kind of a distribution. The one I do use symmetric on is this one right here. I'll sometimes call it bell-shaped, like you see underneath. I'll call it symmetric. This is a symmetric distribution. And sometimes I'll also call it normal. And we'll get to that later in the class as to why I call it a normal distribution. But what you can see is that right here in the center, sort of, if that was a straight line, right there in the center, I have half of my data on the side over here, and I have half that are below it, and I have the center right smack dab in the middle. It's kind of like a mirror image. Okay, so if you've taken, let's say, algebra already, think about something that's symmetric to an axis, and that's what you're looking at here. If I think about something that's symmetric or a bell-shaped curve when I put the data in, I'm thinking of maybe SAT and ACT scores. And so most of the people there are in the middle. Most of the students who take SAT or ACT, they're going to be in the middle score range. And then you'll have a certain number of people that are way up here on the high end, and you'll have a certain number of people that are really far down on the low end. But it tends to be a very symmetric and rolling distribution. The next one we're going to talk about is right over here. It's the right skewed distribution. And the way that I remember this is it looks like it has a little tail over here on the right hand side. So it has a right tail. And so that's why it's called a right skewed distribution. Basically, if you look at the data that we had with the siblings, right? Let's go. Well, I don't think I have that one. Well, we do. We have the dot plot of it. This is a right skewed distribution. Our siblings data is a right skewed distribution. Another example of something that I would find that would be right skewed would be salaries. So if I take a survey of people's salaries, I'll have most of the people right here in the middle, toward this end, but you got, let's say Bill Gates way up here or something like that, or Elon Musk way up here making a whole lot of money, way more than everybody else. Okay. So that's a right skewed, or positively skewed, sometimes said too. So I can write that down for you just so you have it. I tend to use right skewed much more than positively skewed. So they're the same thing. If you look over on the other side, we have one that's left skewed or skewed left. I can also say that's negatively skewed. As I run out of room over there on the edge. And what I'm looking for here is I have a left side tail. So you can kind of see this left side tail over here that strings out, and then I have main bulk of my stuff all the way over here on the right-hand side instead. I think my L disappeared there. Left tail. So if I want to think about something that I would see left skewed data for, I think about marathon times. So if you consider people who are, let's say, world-class athletes, they're going to run in a very short period of time, but the vast majority of people are going to run in, let's say, the 3-ish hour range, right? So you'll have a large group of people over on this side of your times, and you'll have a few that run really, really fast. Alrighty. So those are shapes. We already talked about the distribution for the unemployment data. Actually, I guess we didn't. If we go back to the distribution for the unemployment data, hopefully I'm not making you dizzy, and we look at that, that's also going to be, what do you think? Right skewed, left skewed? Yeah, it's right skewed. So since I have the little trailing edge out here, this tail on this side, and most of my data is right over here, then I have a right skewed data. Alrighty. So I believe that should be the end of this section. Like I said, if you look on the next page in the notes that I upload, there will be information about stem and leaf plots. It's just part of the very front of it, the front page. It's not the whole section for section 2.3. If you're interested in them, go for it and watch section 2.3 on Canvas, but you don't have to.